In our earlier session, we developed Newton's second law, which is also known as the equation of motion. Sum of all the forces equal to mass times acceleration. We applied this equation directly to solve kinetic problems. A simple transformation of this equation can lead to the development of the work energy principle. Remember the kinematic equations that we already have? Velocity is the rate at which the position of a body changes. Acceleration is the rate at which the velocity of a body changes. By eliminating dt from these two equations, we get an expression correlating velocity, acceleration, and displacement. This can be rearranged in terms of acceleration as well. Replacing this expression for acceleration in Newton's second law, we get this new equation. We can now integrate what we have here. Let us look at the left-hand side. We have the expression force times distance. This is called work. We all know work is done when a force that is applied to an object moves that object. In other words, force causes displacement. To be clear, if I push this object and if it moves, work is done. For an example, if I apply the force perpendicular to the direction of motion, the body will never move and no work will be done. If I apply the force at an angle, then part of the force is used to move the object and part of the force is wasted. So be smart when you apply a force to move a body. Let us now take a look at the right-hand side of the equation. The expression 1/2 mv square, as all of you know, is kinetic energy. Kinetic energy is the energy of motion. Any object that is in motion, whether it is vertical or horizontal, has energy. Kinetic energy is an expression of the fact that a moving object can do work on anything that it hits. This is why when a moving object hits another object, there are damages. The right-hand side of the expression contains both final and initial kinetic energy of the particle, which shows the change in kinetic energy. For simplicity, we can denote the left-hand side with the notation U sub 1 to 2 and the right-hand side with delta T. We can now read this equation as work done by all the forces as the particle moves from point 1 to point 2 is equal to the change in kinetic energy. Sometimes this equation is also rewritten in the form where it means initial kinetic energy plus the work done by all the forces equal to final kinetic energy. As you can see, a simple transformation in Newton's second law leads to the definition of the work and energy principle. This principle is very useful in solving kinetic problems involving velocity, force, and displacement. Let us now take a look at examples how to use work energy principle in solving real problems.